MongoDB is a popular open-source NoSQL database management system that is designed for scalability, flexibility, and ease of development. It falls under the category of document-oriented databases, which means it stores and retrieves data in a flexible, schema-less format called BSON, binary JSON. MongoDB is commonly used for handling large volumes of unstructured or semi-structured data, making it suitable for a wide range of applications, including web applications, mobile apps, content management systems, and more. Key concepts and features of MongoDB. Document-oriented. MongoDB stores data in documents, which are essentially JSON-like objects that can hold a variety of data types. Documents are stored in collections, which can be thought of as tables in a relational database. Flexible schema. MongoDB's schema is dynamic, which means each document in a collection can have a different structure. This flexibility allows you to adapt your data model easily as your application evolves. NoSQL. MongoDB is part of the NoSQL movement, which stands for Not Only SQL. Unlike traditional relational databases, MongoDB does not rely on the tabular structure and uses a more flexible approach to data storage and retrieval. Scalability. MongoDB is designed for horizontal scalability, allowing you to distribute your data across multiple servers and clusters. This makes it well suited for handling large amounts of data and high-traffic applications. Replication. MongoDB supports automatic data replication, allowing you to create copies, replicas, of your data across multiple servers. This enhances data availability and fault tolerance. Sharding. Sharding is a method of distributing data across multiple servers to improve performance and scalability. MongoDB supports automatic sharding, allowing you to manage massive amounts of data efficiently. Query language. MongoDB provides a powerful query language for retrieving and manipulating data. The queries are expressed as JSON-like documents and can perform complex operations. Indexes. Indexes can be created on specific fields in a collection to improve query performance. MongoDB's automatic indexing helps optimize query execution. Aggregation framework. MongoDB offers a versatile aggregation framework that allows you to process and analyze data within the database using a pipeline of operations. Geospatial support. MongoDB has built-in support for geospatial queries, making it suitable for location-based applications. ACID transactions. Starting with version 4.0, MongoDB introduced multi-document ACID transactions, ensuring data consistency and integrity in complex operations. Community and ecosystem. MongoDB has a vibrant and active community, offering a variety of tools, libraries, and resources to aid in development and management. Usage scenarios. Content management. MongoDB's flexible schema is well suited for content storage and management in various formats, such as articles, images, videos, and user-generated content. User data management. MongoDB can handle user profiles, preferences, authentication data, and other user-related information. Real-time analytics. MongoDB's aggregation framework enables real-time analysis of data for generating insights and reports. Internet of Things, IoT. MongoDB can store and process sensor data, device logs, and other IoT-related information. Caching and session management. MongoDB can be used to store temporary data like session information and caching to offload the primary database. Catalogs and e-commerce. MongoDB's document structure can be beneficial for building product catalogs, managing inventory, and supporting e-commerce functionalities. In summary, MongoDB is a versatile, document-oriented database that offers flexibility, scalability, and performance for a wide range of application scenarios. Its dynamic schema, support for distributed data, and powerful querying capabilities make it a popular choice for modern software development.